Hello everybody, we're in 5.4 and we're going to look at how to solve polynomial and rational inequalities. So this is a pretty set way to do it, and this is how. So number one, you forget about the inequality and you make it equal, and you're going to solve it by factoring. Second, you're going to put all your answers down in the number line. You're either going to use open or closed circles appropriately. So they're going to be open if it's less than or greater than, and you're going to do closed circles if it's less than or equal to or greater than or equal to. You also put down any values that are undefined. So here, that has to be talking about those rationals. It says we all know the domain of any polynomial is everything. So any value that causes a division by zero situation, you're going to put those on the number line as well. And those are always open. Every single time it's undefined. Undefined is an open circle. And then finally you test values in the intervals to tell which ones work, and you put it all together with interval notation. So we're going to take a look at two examples. Okay, here's our first one. So the directions say solve and write answer in interval notation. So let's see, what do we have? We have a polynomial inequality. There's no equal sign greater than or equal to, and we definitely have a polynomial over here. All exponents are nice, I don't see division. So the first thing we do, we forget about the inequality, we set it equal, and solve. Okay, here I'm going to factor. This looks like x minus 5 and x plus 4. 0, and then I get solutions of 5 and minus 4. Okay, number 2, we're going to put those down in a number line. Normally, when you draw a number line, you're drawing this x-axis. Here I have x values. So we put those down appropriately. So this minus 4 comes before the 5. I'm going to write it first. Here's the minus 4, and here's the 5. The question is, what kind of circles are we going to use? Here we're going to do closed circles because it's greater than or equal to, and these values cause it to be equal. You plug in a 5 into this side, what do you get? You're going to get 0. That's how you found these numbers in the first place. Is 0 greater than or equal to 0? Yeah, it's equal. We want it. Those are closed in circles. Closed and closed. Okay, third step. Now I'm going to test values. So over here, I'm going to try x equals minus 5. I want to know if this interval is in our solution or not. Any number will work to the left of minus 4, but we want to be easy on ourselves, pick something easy to work with. So I'm going to try minus 5. And I'm going to also plug it into the factored forms. It's usually easier to deal with. And that's the awesome thing about factoring. This x squared minus x minus 20 is equal to x minus 5, x minus 4. So I'm going to plug it in, minus 5, minus 5, parenthesis, minus 5 plus 4, and I'm going to see if this actually turns out to be greater than or equal to 0. So here I get minus 10, here I get a minus 1. Multiply them together, I get 10 greater than or equal to 0. That's true, it works, so I know this whole space over here I want it. Okay, now I'm going to try something in the middle, like 0. So try x equals, oops, get rid of that. I'm going to try x equals 0, right? That is in this region here. So I have 0 minus 5 and 0 plus 4. Remember, go back to the inequality part. I'm wondering if that's going to be greater than or equal to 0. This is minus 5 times 4. This is minus 20. And this does not work, right? Minus 20 is not greater than or equal to 0. So what I like to do is I like to put a little x up there or something to remind myself I don't want this part. Okay, last thing, last interval I need to check is this one out here. Give myself a little bit more space. So here, what would be a good number to try? Oh, I don't know. Let's do 6 or 7 or a million or whatever. Any number out here will work. So I'm going to plug a 6 in. I've got 6 minus 5 and 6 plus 4. I'm going to see if this turns out to be greater than or equal to 0. This is 1 times 10, and we get 10. Is 10 greater than or equal to 0? Yes, it works, so I want this region. And now I put it all together. So interval notation, work left to right. I have minus infinity up to minus 4. It's closed, so a bracket. Union, because we got two pieces. Bracket 5 to infinity. Those are all the numbers that will make this polynomial greater than or equal to 0. Okay, let me try this other explanation. This is kind of an advanced way to look at it, but when I look at this side over here, I've got a quadratic, right? We've got an x squared term. Which way does this quadratic open? This guy opens up. Since it opens up, its vertex is a minimum. This is like our x-axis. These are the values that equal 0. I don't know exactly what it does, but I know it's a quadratic, so I know it's going to go something like this. This is your x-axis. Up here we're positive, and here we're positive, and down here we're negative. This thing wanted to know when we're greater than or equal to 0. This has got to be the end pieces. That's another way to look at it, but being able to test values in intervals and make sure they work or not is a very valuable skill. Okay, let's take a look at one more example. Okay, so solve right answer in interval notation. And here I have a rational inequality. I've got an inequality, I've got a rational. With the rational, the first thing I'm going to do is I'm going to find the values that are undefined. So here, when I look at this bottom, I know x cannot equal minus 4. That would cause division by 0, and that's out. And now I'm going to follow the same steps. So first I'm going to set it equal, and I'm going to solve x minus 4, but x minus 5 over x plus 4 equals 0. And here, remember, this is like a fraction. So when are fractions equal to 0? Fractions are equal to 0 when the top is equal to 0 and the bottom is not. So here I set the top equal to 0, and I'm going to solve this guy. The only thing I have to make sure is that this is in our domain. That 5 doesn't cause the bottom to be 0. 0 divided by 0 is undefined. Okay, this value is okay, and that's step number 1. So step 2, we're going to do a number line. Okay, go down here a little bit. Step 2, and I'm going to put down both values. Put down 5, and I'm also going to put down minus 4, and this guy is open. So here this is open since it's undefined. And since undefined, all undefined things are open circles. And here 5 is equality. I'm going to set that to be a closed circle because remember, this was the original problem. X minus 5 over x plus 4. I wanted that to be, check, greater than or equal to 0. And if you plug in 5, you get it equal. Okay, last up, test values. So here I'm going to try x equals minus 5. So I've got minus 5 over minus 5 plus 4. I'm wondering if that's going to be greater than or equal to 0. This is minus 10 over minus 1, greater than or equal to 0. This is 10. Is that greater than or equal to 0? Yep. We want it. Try something in the middle, like 0 would work. So I'm going to try, organize this a little better. I'm going to try x equals 0. It's going to be 0 minus 5 over 0 plus 4. Wonder if that's going to be greater than or equal to 0. This is minus 5 over 4, which is not greater than or equal to 0. I don't want that. So x here in terms of I do not want it. And lastly, something out here. I'm going to try x equals 100. Any number will work. So let's try 100 minus 5 over 100 plus 4. Is that going to be greater than or equal to 0? Yeah, I'm going to get 95 over 104, which is definitely a positive number I want. So I'm going to put this all together. My answer in interval notation is minus infinity up to minus 4, open, union, bracket, 5 to infinity. Again, this is closed because this causes it to be equal. This is open because that's undefined. Alright, and that's polynomial and rational inequality.